Okay, optimization problems in calculus can be solved using your calculator depending on what type of calculus course you're in. Sometimes calculators aren't allowed, but for math applications and interpretations, of course, all exams you're allowed your calculator. So I'm going to show you, first of all, how you can get the answer directly from this equation using your calculator. So here we have a manufacturer determines that a daily average cost of producing Q units is determined by this function here, where Q is greater than or equal, or sorry, just greater than 0. It wants us to determine the number of units produced per day, which minimizes the average cost. Whether you're using your calculator or not, you always have to start these questions by determining which variable do they want you to find. Do they want you to look for C of Q, which is the Y value on your calculator, or do they want you to look for Q, which is the X value of your calculator? So what they're looking for is usually in the last sentence. In this one, it says determine the number of units. So it wants the number of units produced per day. So because it's looking for a number of units, it tells us that we're looking for Q. We do want to minimize the cost, but we want to know what do I put into Q to minimize this cost, not what is the minimum cost. So that is the difference between when we're looking for the Y value or the X value. This is how many do we need to produce. This is what is the minimum cost. So now that we've determined that we're looking for Q, which is the X value of our calculator, like I said, looking for Q, which is our X value at the minimum. Okay. So once we know that, we're going to go ahead and just put this function exactly as written into our calculator. So of course I'm using the Casio. We're going to go into graph. Now I'm going to enter in the equation. Let me just delete what I have. So 0.1231. Of course, these calculators don't have a Q, so we use an X. Minus 0.08 X plus 65 plus, I'm going to get the fraction, 5,000 over X. So once we have that entered, we're just going to hit execute, execute again. So this is one of the problems when solving with your calculator, is you have to try to find the graph. Specifically, find the graph that shows where the minimum is. Well, right away it's telling us that Q needs to be greater than 0, which means that I don't need any of these negative X values. So I'm going to go into V window here, and I know my X min is going to be 0. All right, as for max, really I don't know what we're going to do. So it says daily average cost of producing Q units. Well, I don't know what we're producing, but let's pretend I can produce 1,000 of them in a day. So I'm just going to make that my max. So Y represents our cost, daily average cost of producing a unit. So our cost is not going to be less than 0, because that means that our cost is actually giving us money, which we don't want. So we are going to do that at 0, and I don't know. Let's hope it doesn't cost me more than $500 to make these items. And we're going to see. So I just hit execute, execute again, one more time. Okay. So it is showing me my graph here, but I don't know if it's showing me my minimum yet. So we're going to try. We're going to go to gsolve. We're going to find our minimum. So that did happen to tell us our minimum. So as we wrote here, we want the X value of our minimum. So our X value is 500. So determine the number of units produced per day. So we need to produce 500 units. Units per day. And that's it. That is how you can solve an optimization problem using your calculator.